Hey everybody, welcome to 7.6. This one's getting into double angle and half angle formulas. And this is going to be a 2-day lesson. Today we're going to do the double angles, and then tomorrow's we'll focus on the half angles. Okay, so these are the double angle formulas. Sine only has one. Cosine has 3 versions, but they're actually all the same if you just write them a different way. And then tangent, there's either this formula or tan of double angle is equal to sine of double angle divided by cosine of double angle. So you have some options for tan. Okay, let's try some here. So given sine is 3/5 in quadrant 2, find these exact values. So I'm going to draw a little picture just to see where this triangle is here. So this tells me it's in quadrant 2. And if sine is 3/5, then that's opposite over hypotenuse. And then by Pythagorean theorem, this gets you -4 for this side here. Okay, so sine of 2 theta, we're going to use the double angle formula. It's equal to 2 sine theta cosine theta. So 2 sine theta cosine theta. And then this isn't too bad because we know sine theta and cosine theta just based on their triangle ratios of the triangle here. Okay, so now we have 2 times. Sine of theta is going to be over h, so 3/5, times cosine theta is going to be a over h, which is -4/5. And then just multiply through, and that gets you -24 over 25. -24/25. That's it. Okay, so these are actually pretty easy. Okay, B, cosine 2 theta. You have a choice of which one you want to use. I'm going to use this one just so we have a common denominator, but you guys can totally pick. So we have to do cosine squared theta minus sine squared theta. So cosine squared minus sine squared. Well, cosine of theta we know is -4/5. And we want to square that. And then sine theta is 3/5, and we want to square that. Okay, so if you square those, it's 16/25 minus 9/25, which we end up with 7/25. So again, pretty easy. And then for tan of 2 theta, I'm going to use the formula up here. It's 2 tan theta over 1 minus tan squared theta. All right, and we're just going to plug in tan. So 2 times, well, tan theta is O over H, so -3/4. And then it's over 1 minus tan theta squared. So -3/4 squared. All right, so if we kind of simplify this a little bit, 2 over 4 reduces to 2. So this is -3/2. And then on the denominator, it's going to be 1 minus 9/16. But if we get a common denominator, this is going to be -3/2 over 7/16. And again, that's just by getting a common denominator here. But then dividing is the same as multiplying by the reciprocal. So instead of dividing by 7/16, we're going to multiply by 16/7. And then if we simplify that, let's see, these cross reduce to 8. And that ends up being -24/7. Now, possible shortcut, tan is really just sine over cosine if they're all double angles. So if you would have divided this by this, you would have also gotten this. So that might have been easier if you have them all in a row. All right, great. Let's move on to the back side here. Okay, solve the equation. So this one, you can't just use the zero property and set them both equal to -1/2. That only works when it's 0. But sine theta cosine theta, isn't that almost close? If there was just a 2 out front, then we could replace it with the sine double angle identity. So what if we just multiplied both sides by 2? That's legal. We can multiply both sides by 2. Then we have 2 sine theta cosine theta equals -1. And then 2 sine theta cosine theta, let's replace it by its double angle identity, sine 2 theta equals -1. And here, I'll put this in parentheses. Okay, so now we need to figure out when is sine -1. And we're going to have 2 theta equals those angles. Okay, so when is sine -1 on the unit circle? That's 3 pi over 2 plus or minus 2 pi k. All right, but we got to get theta alone. So we need to divide everything by 2. And now let's get our answers. So theta equals, well, this would be 3 pi over 4, and then plus or minus, these would cancel, just pi k. All right, so we're going to have 2 answers, 3 pi over 4, but then if you add pi, it'll also get us 7 pi over 4. And then you won't be able to add pi again, or you'll be out of the 0 to 2 pi restriction. All right, this one's going to be an identity. They want you to verify that this side actually is the same as this side. All right, so the left-hand side looks more complicated. And I don't know, to me, since it's cosine and all of our cosine double angles are in terms of sine and cosine, I'm going to try to just convert cotangents and tangents into sines and cosines. All right, so cotangent is going to be cosine over sine. Oh, that's a minus. And then tan is going to be sine over cosine. And then in the denominator, cotangent is going to be cosine over sine. But now plus, and tan is going to be sine over cosine. Okay, so let's get some common denominators. If we get a common denominator on top of sine, cosine, then this one needs an extra cos, so it becomes cosine squared. And this one needs the sine, so minus sine squared. I'm assuming that you guys know how to get common denominators here. Now this one, common denominator is also going to be sine, cosine. And this one will need the cosine, so it becomes cosine squared, plus this one needs the sine, so it becomes sine squared. Okay. And then dividing is the same as multiplying by the reciprocal. So if you flip this and multiply, we're going to do that next. Okay, so now this is gone because we multiplied by the reciprocal. Well, sine cos cancels with sine cos. And then actually, if you sin, it'll cost you. This is actually just a big old 1. So all that's left is this, cosine squared minus sine squared. And actually, if you guys look, that is equal to cosine of 2 theta. So we are done because that's what you guys wanted. All right, so that was just a little identity. And then the last one, pi over 12, we don't know, right? It's not on the unit circle. But let me pull out our tan here. So this one's actually working backwards. See how this kind of fits this identity here? But alpha or A is just pi over 12. So if the angle is pi over 12 and this lines up with this side of the formula, we're just going to plug pi over 12 into A and just evaluate the left-hand side. Okay, so I guess what I'm saying is this is really equal to tan of 2 times that angle, which was pi over 12. But then what is 2 times pi over 12? That's just pi over 6. And then we know that tangent at pi over 6 is root 3. Let's see, pi over 6. Sine is 1/2 and cosine is root 3 over 2. So it's 1 over root 3. But if you rationalize it, it's root 3 over 3. Okay, so this was just like the reverse order of the tan double angle. All right, thanks for watching, guys. That's it for the double angle problems.